General relativity states that time is different for every observer. Depends on times of reference. It is wrong to say time is different for every observer based on their frame of reference. Time is fixed for everyone across the universe. There is only one time, fixed. But how we experience the time, it depends on the frame of reference. It is the experience of time, not the time itself. Time is fixed. There is only one time. And it doesn't slow down, doesn't go fast. There is only one time. But different frame of reference experienced it differently. So it is the experience of time makes the difference. Why we experience time differently? It is because atoms behave differently under different conditions. That depends on the speed they are traveling and the gravitational force they are exposed affect their behavior. So, for example, satellites orbiting Earth experience time differently from the Earth. It is because of the speed they are traveling. The atoms on that satellite behave differently, slows down. It cannot behave just like they are on Earth. And that affects the clock's atom as well. So it cannot measure the time just like on Earth. They are affected by the speed they are traveling. That is why we calculate satellites' time based on Earth and update their clocks. But the fixed time is the same. For time is the same for the satellite and is the same for the people on Earth. The only difference is their experience. The time is slows down because of the conditions there on the satellites orbiting Earth. Because atoms behave differently under different conditions, that doesn't mean the fixed time for the universe is not the fixed clock. Fixed time is not ticking. It is still fixed, but it depends on the conditions. Atoms behave differently and you experience the time at different speed. For example, if you are affected by a black hole or you are near it, inside it, for you, time is stopped. But that does not mean the time, fixed time for the universe is not ticking. It's still, the time is passing, but because you are affected by the black hole gravitational force, you are not experiencing the time. That does not mean time is not passing. Time is still passing. So, because atoms affected by the conditions like speed and gravitational force, clocks atoms also affected and they cannot measure the time. For example, based on Earth, it measures the time depends on how they are affected by the conditions. Basically, they cannot measure the time based on Earth's conditions. They measure the Earth's whatever conditions they are in. The atoms behave accordingly. That does not mean the fixed time is not ticking, it's not passing. It is still passing. So we cannot measure the time on those extreme conditions, or if accurately based on the Earth's reference. But we can calculate it. If you know the speed, if you know the distance we traveled, if we know the gravitational force strength, we can calculate the time, how fast we experience the time. For example, based on the world's frame of reference, time is passed in Earth 10 years, and we are on spaceship. Our clock is showing we only passed 1 week based on our clock, based on the conditions on that ship. But we couldn't measure it, but the time is still past 10 years. We only experienced on that spaceship only 1 week. But the time is still past. We cannot measure that time by accurately based on the frame of reference on Earth, but we can calculate it and say, yes, 10 years passed on Earth and our clock shows only 1 week passed. But according to our data, the time, the distance we traveled, the speed and gravitation force we are exposed, we must, our atoms behave differently from Earth, and so we only experienced 1 week within 10 years. 10 years still passed, but only you experienced 1 week. So it is wrong to say when you explain general relativity, time is different for every observer. Experience of time is different. There is only one time for the entire universe, everywhere. But because atoms behave differently under different conditions, we cannot measure the time by looking at the clock, but we can calculate it. So we can say from every frame of reference, experience time differently, but the time is fixed, never stops, never go fast, never slows down. But you experienced it differently because of the atoms behave different under different conditions, like the speed, atoms affected by the speed, atoms affected by the gravitational force, so they slow down. If we give an example, for example, if we say, when you explain general relativity and say this, time stops or time slow down, if we apply the same thing on Earth, for example, we cannot, based on general relativity, it says if you go certain speed, the time slows down, or time is stop if you go at the speed of light. That's the way of freezing things on that spaceship. If you are traveling on a spaceship and at the speed of light, the atoms freeze. Can we do this on Earth? Yes. For example, I'm giving an example. If you take two embryo and frozen embryos and give one embryo life, and that embryo lives certain times, when that embryo dies, and give the other embryo life. So for the second embryo, when life started, based on the general relativity explanation, time did not move while the other living. No, time is still moved, But that embryo, frozen embryo, did not experience the time. So when we give life, it start experience it. It didn't stop. Time didn't stop for that embryo. So this is a way of explanation. So it is the when explain general relativity, it is wrong to say the time is slowing down and time is stop. It is the experience of time is affected by the conditions.